Hello and welcome. Myself Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. I am taking the paper named Control System, paper code PCEE503. Today, my topic is Introduction to Control System. Lesson objective. After end of this topic, student will able to understand and analyze the properties of control system. What is control system? So why the control system is required? This is the first question that arrived when you approach to this subject, the control system. So let us take an example. The example of our fan that we have seen in our house. The fan that is rotated and it can rotate in different speeds. So this speed, depending on the circumstances, the atmosphere in the room is hot or it is cold. So depending upon that, we have to adjust the speed. So that's why we are using a regulator. So this regulator is used to control the speed of the fan. So that is why the conception of the control system is come in order to control a particular system, or otherwise in order to make a system stable one. Okay, that is why the conception of the control system come, and the control system can be classified into two parts. One is called the open loop, another is called the closed loop control system. So what is open loop control system? So let draw a block. This is a block. Okay, just like that. This is the block. This is known as open loop system. OL. And this is the output from the system. And this is an excitation in the form of input is given to the system. So this is called a open loop system. Why? There is no feedback, only the input is given and only we are getting the output. So this is generally known as open loop system. So the open loop system is that input doesn't depend on the output. So this is called the open loop system. So any type of time dependent system is the open loop system. The example is the washing machine. So this is generally known as open loop system. So this is the block diagram of an open loop system. An open loop system, and excitation is given, and the output is in the form of input, and the output, the response that we are getting. So this is generally known as the open loop system. So what is the closed loop system? So closed loop system is that input is dependent on the output. So now we have learned, just recall our memory, why the control system is required and what are the classification of control system. So it is obvious that the control systems are of two types. One is called the open loop control system and another is called the closed loop control system. And the diagram of the open loop control system is given here. This is the diagram of an open loop control system. Only input is there and the output is given, found. Okay. So example is the washing machine. Now we are coming to the closed loop control system. So let's take the why the closed loop control system is there. Why the conception of the closed loop is coming? Closed loop is coming because our main motto is to control. What we can control? We can minimize the error signal. This particular portion, this is called the error signal. We can minimize this error signal in order to make the system output or the system response nearer to the desired one, or in order to make the system a stable one. So that is why we are using an feedback, or so called the closed loop control system. So let's draw it. Let's draw that particular block diagram. So this is an plan transfer function or a plans. Okay. So there is a summing point that I have taken. This one is the first sign, and we are providing an excitation in form of input, and we are getting the output in the form of C. Now we are introducing an feedback from the output, and this is called the feedback element H. And this is the feedback path that is given to the summing point. Okay, in order to minimize the error signal. So which part is the error signal? This part is known as, this signal is known as error signal. This signal is known as the error signal. So our main motto is to minimize that error signal to get the desired output. So this is a feedback part. This is known as summing point. So this entire phenomenon is known as closed loop, because we are creating a loop and we are closing the loop with the help of the feedback. Okay, that is why this is called a closed loop. We are closing the loop. We are taking the feedback from the output to make the output a desired one in order to minimize the error signal and in order to make the system a stable one. This is called the closed loop. So now this one, this is called the closed loop system. There is a plant, there is an error signal, the output is C, this is the feedback element, this is the feedback path, this is the summing point, the excitation is given in the form of input, and output we are obtained is error signal must be minimized. So are it known as reference signal or the reference input. This figure is known as closed loop block diagram. This is a block diagram that we have first formed a block from an open loop to a closed loop in order to minimize the error signal, in order to provide a output which is desired one, in order to improve the stability. So this is the main objective of an control system. So this is the main objective of a control system, to nullify the error signal and to improve the stability of the system. Okay, so now whatever the signal that we have taken till now, it is in the time domain. Okay, so another domain we have, it is called the frequency domain. So what is the frequency domain? Just we have to see it. So the frequency domain is generally sigma plus j omega. So this is the frequency domain. Okay, so we till now we have drawn the xy plane. Now we will draw sigma j omega plane, generally known as S plane. We will all the poles of the system is lying on the left hand side of that S plane. The system is said to be a stable one. Okay, so we can able to meet the stability of the system with the conception of S plane, sigma plus j omega, that the frequency plane that we have introduced. The plane is called the frequency domain. So let us consider this block. So we have now very much this is known to us very much, that the frequency domain. What is the frequency domain? This is called the S plane domain, and if the poles are lying on the left hand side of the S plane. So our motto is to make the poles on the left hand side of the S plane to make a system stable one. Okay, so this is the most important phenomena in case of the control system study. So let us take a transfer function in time domain called GT, and output is generally known as CT, and the input is generally known as RT, the time domain. So the output CT that is given here, CT is nothing but the convolution of GT and the RT. Okay. So this is generally known as the output in the time domain. Now let that output is converted to the frequency domain or the S domain. Okay, so this is the frequency domain output. So what is the frequency domain output? So what is the frequency domain output? So let's take a block called G is the transfer function in the S domain. Output is CS and the input is RS. Okay, this is the so the CS, the total output can be written as GS RS. GS RS. So it is found that the CT, the time domain output, is nothing but the Laplace inverse of the output that we get in the frequency domain. So in the S domain, that output we have get, taking the Laplace inverse of that particular output, we will get the output in the time domain. So just recalled our memory that what we have learned is that the introduction to the control system is there because in order to improve the stability of the system or in order to get the desired output. So the desired output can be found by minimizing the effect of error signal. So the error signal effect can be minimized in order to make an open loop signal a closed loop one. This is a kind of sensing, the sensor type, the feedback that is fed to the summation point, so that the difference between the input, that is the R, and the feedback is minimized, so that means difference between the R and the C is minimized, means we are minimizing the gap between the R and C is minimizing, means we are minimizing the error signal. If we can able to minimize the error signal, that means the stability that we have obtained from the transfer function, a stability that we are going to obtain, which is improving. And this is the main part in order to go or in order to study the control system, the stability of the system. And another important part that when I move from the time domain to the Laplace domain, means the S domain platform, it is found that the poles are lying on the left hand side of the S plane that we have seen. The system is stable. So our main motto is to make our system stable. So the open loop system and the closed loop system that we have discussed today, the control system, the introduction to the control system stability that we have discussed today. We have discussed how to form the block diagram and what is the feedback and what is the effect of the feedback and the feedback element, and the time domain and the Laplace domain that we have, the frequency domain, and in both domain how we can make a system a stable one. This is our main finding or the main thing that we have learned in case of the control system. So the control system is basically required in our daily life phenomenon, where we can try to input the stability of some systems. So in that particular purposes, the control system is very much helpful for us. So this kind of sensors that we are using, the sensors are sensing the particular output that is given, and it sensing back to the input that the error signal can be minimized. So again that I am repeating that the open loop system is generally the input of the system doesn't depend on the output. But in case of the closed loop system, the input is dependent on the output. In a time dependent system is the open loop system. Generally it is known as, the example is the washing machine of an open loop system. But the control system study is generally the conception of the closed loop system. The closed loop system conception is there because we have to sense the output. We have to feed it back to the input in order to make a system stable one. Our main study of the control system is the stability of the system. The stability of the system, how we can able to improve the stability of the system. And the domain that we have discussed about the time domain and the frequency domain, or the S domain, there is a sigma plus j omega domain that we have already known. So in order to find the time domain analysis from the frequency domain, only the Laplace inverse can be done to find the Laplace inverse can be done to find the time domain analysis from the frequency domain. So this type of study of the control system is done because to improve the performance of the system. And also the behavior of the system. So what we have learned that control system is an integral part of our lives and play very important role that we have already seen in today's lecture, that we have already seen that control system is an integral part of our lives and play a very important role. From a simple bread toaster to complex power plant, control systems are all around us and inseparable part of modern society. So from our daily needs, daily life requirements, that is from a simple bread toaster to a complex power plant, control systems are all around us and inseparable part of modern society. So launching a satellite in orbit, regulating a power plant, tracking enemy on radar are some of man-made control system. Those are the examples of man-made control system, that is
launching a satellite in orbit, regulating a power plant, tracking enemy on radar. Control system that is occur in nature also. Human body is a great example of complex control system because we have so many control system by nature, that is respiratory system of us, digestive system of us. So the human body is another example of complex control system. So it is clear that we are generally surrounded by the control system, or control system is an intricate part of our lives, daily lives. So this is that we have already seen a basic block diagram of control system. That is, there is an input in the system, and this is the control system which control that particular input in order to generate an output from that particular system. This is the basic block diagram of control system. So a control system, that is the definition is given that a control system is an arrangement or a combination of various physical components that is also called subsystems, connected in such a manner so as to attain a certain objective. So the definition of the control system is that a control system is an arrangement or a combination of various physical components that is generally known as subsystems that are connected in such a manner so as to attain a certain objective. The input the input of a control system is defined as the excitation that is applied to the system from an external source to attain an output is called the input signal. So input is generally the excitation that is applied to the system from an external source to attain an output is called the input signal. The output. The output is the actual signal that attained for system is called the output signal. The actual signal that is attained from the system is called the output signal. Control action. Control action is a quantity that is responsible for activating the system. So the control action is a quantity that is responsible for activating the system. So we have seen the definition of control system: input, output, and the control action. So the control system must have the following parameters or the following things, that is called the input, the outputs, and the third one is the an arrangement of subsystems to achieve the input output combination, because our main objective is to find the output from a particular system when an input is given to a system that we have already seen. So the control system has also will have that particular arrangement of subsystems to achieve the input output combination. So we have already seen that depending upon the types of the system, or depending upon there are two types of system, that is depending on the configuration of the components, that we have already seen that one is called the open loop system and another is called the closed loop system. There are two types of system, one is called the open loop and another is called the closed loop system. So when you concentrate on the open loop system, So the system in which the output, that is the output of the system, has no effect on the control action is called the open loop system. That is, it doesn't automatically correct the changes in the output. So if I see a simple block diagram of a control system, it is given that an input signal is given to a controller, and after controlling that particular input signal, it is feeded to a plant, and from the plant it is an output that is obtained. So a system in which the output has no effect on control action are called the open loop control system. That is, it doesn't automatically correct the changes in output. A system in which control action, that is the main part, is independent of the output of the system is called the open loop system. A system in which the control action is independent of the output of the system is called the open loop system. In open loop system, the output remains constant for a given input, provided the external conditions are same. So in case of the open loop system, the output will remain constant for a given input, provided the external conditions are same. There is no connecting action taken place in an open loop system. That is, there is no feedback. There is no feedback in this system. So that is why it is called the open loop system. It means there is no connecting action taking place in an open loop system. It is a simple configuration of an open loop system. It is clear that it doesn't automatically correct the change in the output. And those systems in which the output has no effect on the control action are called the open loop control system. So some examples of the open loop system that we have already discussed is the electric hand dryer, automatic washing machine, bread toasters. Bread toaster are the general example for the open loop system. It is the electric hand dryer, automatic washing machine, bread toasters are the general examples of the open loop system. So what are the advantages of an open loop system? The advantages are it is simple construction and the design. Open loop systems are economic. They can easily maintained, means easy maintenance, and the stability of the open loop systems are more. So the simple construction and design, economic, easy maintenance, and the stability, those are the advantages of an open loop system. So what are the disadvantages of an open loop system? The disadvantages of an open loop systems are incorrect and unreliable internal disturbance. Recalibration is required time to time because it's the absence of the feedback path in an open loop system. So it is incorrect and unreliable. Internal disturbance are there in the system, and recalibration is required time to time for an open loop system. So a closed loop system, a system in which the control action is dependent on the output is called the closed loop system. It is clear from the definition that in case of the closed loop systems, we must have a feedback path that we have already seen here in this diagram. So a system in which the control action is dependent on the output, the control action is totally dependent on the output is called the closed loop system. So closed loop system means a system in which the control action is dependent on the output is called the closed loop system. In closed loop system, the output is constantly monitored and adjusted to the required value of the system, it is clearly seen that the output that is continuously monitored with the help of that feedback element or the sensing device in order to obtain the desired output of the system. So that is why it is called the closed loop system. The output signal is feedback and compared to the reference input. Depending upon the difference between the output signal and the reference input, corrective actions can be taken by the controller to adjust the output. So here the input signal is given to a transducer. So we all know that transducer is a device that converts variation in a physical quantity such as pressure or the brightness, etc., into an electrical signal or vice versa. It is a conversion of an physical quantity into an electrical signal and vice versa. So here it is clear that output is monitoring here with the help of a sensing device or feedback element, and it is clear that depending upon the difference, that is a summing block that we have already seen in our discussion, this is called the error signal. So depending upon the difference between the input and the feedback is called the error signal. So depending upon the difference between the output signal, that is the output signal, and the input is difference between the input and the output signal is known as the error signal. So depending upon those two signals and the reference input, corrective actions can be taken by the controller, this portion, to adjust the output so that we can get the desired output from a system. That is the main part of a closed loop system, and it is clearly seen in this figure. So some example of closed loop systems are automatic electric irons, voltage stabilizer, DC motor speed control by tachometer, missile launcher. So the advantage are those: accuracy is high, reduce the effect of non-linearities, high bandwidth. So it can facilitate the automation. Disadvantages are complicated in design and maintenance are very much cost. It is costly in maintenance and there's a problem in the stability. So those are the basic disadvantages of a closed loop system. So advantages are given that accuracy is high, reduce the effect of nonlinearities, high bandwidth, and it can facilitate the automation. But the disadvantages are the facilitates the automation. The disadvantages are the complicated in design and maintenance are the costly maintenance, and there's a problem of stability. So there's a comparison between the open loop and the closed loop system is that for the open loop system, no feedback, hence feedback element is absent. For the closed loop system, feedback exists, hence feedback elements are exists. No error detector in open loop system. For the closed loop system, the error detectors are there. For the open loop system, it is inaccurate. For the closed loop system, it's accurate. For the open loop system, it is highly sensitive to parameter changes, where in case of the closed loop system, less sensitive to parameter changes. In case of the bandwidth, the open loop system has small bandwidth. For the closed loop system, the bandwidth are large. In case of the stability, the open loop systems are stable, but the closed loop system may become unstable. For the economical aspect, the open loop systems are economical, but in case of the closed loop system, it is costly. The example for the open loop systems are coffee maker, air dryer. For the closed loop systems, it is guided missile, servo voltage stabilizer, and those are the open loop, the examples of a closed loop system. So this is the difference between an open loop and the closed loop system. So we have done a comparison of open loop and closed loop system. So feed-forward system, it is a feed-forward system. The output of one stage of the control system is to send to improve the overall performance of the control system. It is used whenever there is a disturbance. So this is the general control system. This is known to us. And here we are, a disturbance is given here. And this is called a feed-forward system. So in case of the feed-forward system, the output of one stage control system is sent to improve the overall performance. The output of one stage of the control system is sent to improve the overall performance of the control system. So whether there is a disturbance in the system, we are generally use the conception of feed-forward system, and there is a general construction that we have all seen for the part for a control system where there is a disturbance. We are using the conception of feed-forward system, and a sensor that is used in feedback path. It is a device which detects or measures a physical property and records, indicates, or otherwise responds to it. This is known as a sensor. So this is a system, and here a feed-forward system is there, whether there is a disturbance or occur in a system. So the design process is, we have a physical system. From there we draw a functional block diagram, and we are convert to a schematic diagram, draw a functional block diagram, then we are converting it into a symmetric diagram. So we obtain a precise block diagram or signal flow chart. From there we get a transfer function, and then from there we analyze by checking for stability and see if specifications are met or not. So this is the entire design process of a control system where there is a physical system are there. We draw a functional block diagram of the physical system. Then we are converted into a schematic diagram. Then we obtain a precise block diagram or the signal flow chart or signal flow graph. From there we draw a transfer function of the system. And then from the transfer function we will comment or analyze by checking for stability. The specification are met, we will comment from that particular transfer function on the stability of that particular system. So this is the entire design process of a control system. So we have seen that control system are generally, one is for the open loop and closed loop. We also see the difference between the open loop and a closed loop system, and some example and advantages and disadvantages of open loop and a closed loop system, followed by how to design a control system. We have already seen that there is a physical system is there, so we draw a functional block diagram of that system, then we are converting it into a schematic diagram, followed by obtain a precise block diagram or signal flow chart. We will get a transfer function from that and analyze by checking for the stability and see if specification are met or not. We will comment on the stability of that particular physical system. So today we have learned about the control system, what is control system, why control system required, and also the different types of control system along with their comparison with suitable example and how to design a control system. And also the block diagram of a control system, of a system, how to design a block diagram of that particular system, and also we will see the advantages and the disadvantages that is related with open loop and closed loop system. Thank you.